Hey, what's up everyone, and welcome to this week's installment of the Fabricator Series Segments, where every single week I upload one more chapter, sometimes two, of how to build a tube chassis front end, which is demonstrated on this S13. So, if you are not subscribed already to the Fabricator Series YouTube channel, absolutely go down right now and push that button so you don't miss the next week's uploads. If you're not familiar with the Fabricator Series, head over right now or after this video to the fabricatorseries.com, and there you'll find the build blogs on how to build a tube chassis front end, where each week there will be another episode posted, and in there you can get onto the discussion of everything, ask questions, talk about it amongst everybody else, and all kinds of other good stuff. There's also a lot of great stuff for you to learn while you're over there. You can also check up on facebook.com/thefabricatorseries. There's always another upload, another update, something else going on, and I'm also a big fan of Instagram, so head over to Instagram at the.fabricator. Check all the information below here, and I'll have all of that there. If you need to get a hold of me, send a message, drop a comment, drop me an email, do whatever you gotta do, and I always try to get back to you. So without any further delay, here's this week's episode of how to build a tube chassis front end. Okay, so moving right along, we need to make some space here for the radiator. And you would probably be wondering, well, it's already got space for the radiator if it actually sat where the radiator was going to sit. But in this case, it's not. It's a little bit special here. We're going to end up V-mounting the radiator and building an intercooler for the top of it. So to make sure that these brackets do absolutely stay in place while we ditch this lower radiator core support, I'm just going to clamp in a piece of flat stock real quick, nice and snug, and that should keep them from shifting in and out, because we'll still have to place a new piece in there, a fabricated tube, with the correct mounts on it that will allow it to still bolt in the strut rod brackets. So, get that nicely tight fit, it's not going to move. I'm going to put a couple of reference lines on there just to be on the safe side, in case it does shift on me. I know exactly where they sat. I'm getting all unbolted. After that will come the fun part. Okay, so now with it all unbolted, just going to sneak the saw in here. I'm going to save that lower radiator core piece for later. Turns out this was already busted out of its spot welds, so that'll save us a little bit of trimming for later. Do still have to cut this one out, which will be no big deal. Most of these spot welds probably just break out. If this side came out easily, the other side's most likely going to. Okay, so we got to get this lower mount bar in place. I'll use the same 1.5" variety as I have before. I'm just going to take a measure with the cheater. Chassis rail to the start of the bend, 5 inches. So since each side, to end up figuring out how much space in between before we start our bends, we're going to subtract 5 inches from the total width off of each side. So 10 inches out of the total width of the chassis rail. Let's see, we got 27 3/4, which actually I'm going to round up to 28. Just because it's okay if it's there's a little bit more bend on it. In fact, the amount that we have to trim off of the bend anyway, in order for it to mate here, is going to get more into the bend. So if we give it just a little bit extra, then it'll actually come out pretty even. So, okay, so as we measured, we had 18 inches in between the beginning of each bend in order to make those 2 points that we needed to actually mate up at on the chassis or the lower bash bar. So each bend is going to cost me about 8.5 inches worth of tubing, but I added a lot more to it. Usually I add about 12 inches post the beginning of the first bend, because it has to still have enough to get through the die. Sometimes it takes a little bit more. So This piece I actually cut at 48 inches instead of the 42 like I probably would have. So there's a whole lot extra on here. So half of 48 inches is 24 inches. And then half of 18 inches is 9 inches. So we're going to mark it 9 here. And mark it 9 here. So these points right here will be the beginning of each of my bends. I'm going to do a 90 degree on both of them. Feed this into the die. Make sure my seam is on the inside. This is regular electronically welded steel, 1.5 inch 120, I forgot to mention. I'm going to use the thicker stuff down below because it's going to take the most impact. So I'm going to get it set right on my line. And the seam will be on the inside of the bend. Get this locked down nice and tight. Because over time, as you're bending tubing, in all actuality, it tends to shift or loosen up here. So when you get to about 7 degrees, just before you have to adjust the die, I usually go back and tighten it down a little bit. So set my preload, 0 at the dial. Let's give this sucker 90 degrees. Alright, let's slide this back in again. Time to do the other side. Now, of course, the very, very important step that I go over in every single video is about how not to bend a crooked bar. Okay. And the way we accomplish this is getting this snug here. Grab the dial, or the protractor, and set it on my bender. I'm going to ensure that this is on 0, which it is. I'm going to check it this way as well, and we're dead on 0. So I'm going to set it on this leg, and we're going to clock it to ensure that it is in fact on 0. The reason for doing this, again, is so that when you bend it, you don't have one leg of it going this way and the other leg going that way. You want it both dead on and even. Now, that's about it. Now we'll get it all mounted up and find out how much we actually have to take off. Alright, so we have it semi-fitted. Kind of have an idea about where we need it to go. I'm just going to kind of set it up there to just get a better concept of where I'm going with this. So where I want it to land, just to be on the safe side, I'm going to kind of overcut it just a little bit because we're going to need to notch it out and whatnot. So I'm going to let this cover about half of the tube, and I'm going to let this side. Just one side though. So now when I take my tape measure, I'm going to measure the opposite side since we have the same legs on both sides. Since we started working from the center outward, I'm going to measure up from this end over here to up there for the same measurement as this side, and then we'll cut it down to length and then get our notches put in. Alright, so this side measures out at 7.5 inches, so I'm going to take 7.5 off of this side. Which in all honesty, when I put this into the saw here, it's going to be on the bottom side, or the opposite side, depending on however you want to look at it. But we'll look it up. Make sure it's on both sides, 7.5 inches. Feed this first tube in. Try to get it as straight as possible. That's about right. Okay, almost looking like maybe I'll have to take just a little bit more off, but let's get to, you know what, let's just throw a notch in there and see how close we get. Okay, so it took a few minutes to get these notches to get right where I needed them to be, but now they just snap fit perfectly into place. Put some pretty tough tacks down on them. That ought to hold. So now we'll get to making the brackets to bolt these back on. Alright, so if you notice here, we actually did some really awesome part swapping action. Got some donor parts from the other vehicle he was building previous to this one. So the whole suspension, front end, all of that's been swapped up. Everything's been nice and cleaned up, and of course now we have to make our tabs to mount our brackets in. So we'll start by getting a measurement here. Looks like I'm going to cut a piece about 3.5 inches wide to cover this much of it. We'll use, let's see, we'll use some 1.5 inch flat stock. That should cover it quite nicely. And we'll have a distance, a hole spacing of 1 5/8 inches. So I'm going to cut 2 pieces of that. And of course we have to wrap the bracket around to radius this tube. And we'll get it all set up real quick. Alright, well, I've got my flat stock actually locked in a vise. Since this is where I'm going to be working on it, I figure, hey, let's just set up a really awesome camera shot like this. So here we are. Now, the tabs that we have to create, or the bracket tabs, or the brackets, whichever one you want to refer to them as, they have to have a certain profile cut into them, and they have to actually wrap around the tube, as well as provide a platform in which to bolt the brackets to. So the section around where they made around the tube is going to have to be welded on to the lower radiator core tube that we placed in there earlier, and then of course the bolt holes that we measured out just a moment ago. So I did say originally that 1.5 inch tube would be great, and that's what I wanted to use, but I'm actually going to change it up a little bit here, and I'm going to go with 2 inch tube, or 2 inch flat stock, because it'll give a little bit better coverage on the tube when I cut that profile. So this is a piece of tubing, an 1.5 inch variety, and I'm just going to set it on here so you can kind of get an idea of what we're talking about. This section right here has to be cut and profiled in order to make a tab that mounts up to the side of it, because there's going to be a lot of impact and a whole lot of force that the front end there is going to be subject to, of course, hitting and whatnot. So the better bracket would be one that actually wraps upward, or gives an upward support and contours around the lower radiator core tube. So this section has to be actually created here, and then if we look at it here, the bolts themselves will actually be bolted up through here, nut and bolt. So you'll see all of this as we go along. I guess the best way to describe all of this is just to build it up and let you see how it comes along here. So in order to get that contour, we're going to do some little trick work here. In order to get that contour and cut out 2 pieces at once with only 1 hole, this is also per side, so we're going to actually measure this out and get right to the center of it. So our tab that it has to cut with in the side profile of it, or viewed from the side, is going to be 4 inches long total, and each one is going to be 2 inches in length. So we'll make a 2 inch mark, we'll make a 4 inch mark. I'm going to use my square give myself some really good reference here. These are my 2 reference lines. Okay, so now we have to actually get ourselves a center mark here. Find out where we're going to end up cutting it. So half of 2 inches is 1 inch. This is where the pilot of our hole saw will go into. Now, in order to center up the tube, because I'd like to get it just dead on, and that's just the way that I do things around here, and I really like, we're actually going to center it up. So half of 1.5 inches is 3/4 of an inch. So we're going to measure outward 3/4 of an inch there. Measure outward 3/4 of an inch there. And the difference between 1.5 inches and 2 inches is 1/2 inch. So that's 1/4 inch on each side. So I'm going to measure in 1/4 there. Measure in 1/4 here. Now I'm going to take my tube. I'm going to place it on all of those marks. Now our tube is actually centered on the flat stock. I'm going to trace it out. Now, this is going to be for another visual reference. This section will be cut out. Now, I'm going to take the square, even though that's kind of an ugly mark there. we'll take the square and just run a section of it up from the side of it, tangent to the side up to the top. Now I'm going to connect to the bottom corner, to the top of that tangent line. We'll do the same thing over here. That is now the cut line. So when we cut here, this piece will be gone. When we cut here, this piece will be gone. And of course this center section here, this will all be gone. And that will create the side profile of our tab. So the base plate, that 3.5 inch width, will actually be welded here. And we cut this in half, we have 2 tabs. So since we have 2 sides, we have to make this yet again. So we'll make this here, 2 and 4 inch. And we'll repeat the same process that we did earlier. So if you're a little confused still, that's okay. You'll see all this come together, and I'll definitely show you how each piece fits in there as soon as we get them all cut out. So I'm going to finish measuring these up, and we'll get to cutting. Now, some people have asked a few times here why I usually drill holes out at slower speeds, and it's usually because I get a nicer hole out of it. So you can see, even though, it's because we do it by hand, it's still not the perfect hole, and I didn't use anything to hold the pilot in there, but you get the idea. So if we were to cut this in half right here, we have 2 sides of a tab. So let me get this other hole drilled out, and we'll be good to go. Alright, so of course these will have to be cleaned out just a little bit to get that nice contour and whatnot, but clear some of these chips off of here. Now we have, if we were to cut this in half on both sides here and then cut these tabs out, we now have the side pieces. Alrighty, so each one of our tabs was to be 3.5 inches long, or wide, depending on how you want to look at it. So we need 7 inches total of work room here. I've got about 8 there, and we'll just mark that out for right there. We won't need this much at the end of it. So 3.5 inches. Let's just do it this way. Make it a little bit easier to see here. 3.5 inches right there at the center of it, of each one. And of course our bolt spacing was 1.5 inches, so 1/2 inch is 3/4 of an inch, but we need to measure that from our halfway mark between 3.5 inches. So half of 3.5 inches is 1.75 inches. So we'll measure and mark out 1.75 inches on each side. And again, 3/4 of an inch from each one. So 3/4 there, 3/4 there. These 2 lines right here, which we'll have to center in just a moment, will be the location of our bolt holes. And we'll do the same thing over here. 3/4 of an inch there, 3/4 of an inch there. Half of 2 inches is 1 inch. So 1. And 1. Alrighty, so all we really have to do now is make all of our cuts and then weld all of this together after we get it all cleaned up. This piece here would be half the tab. So we'll just keep on cutting these out, and eventually we'll have 4 of these. Alrighty, so I get the first piece done. You can see how all of these actually fit together. So as we put it in here, this will wrap around the tube here, and of course the hardware will go through there. Plenty of clearance, plenty of strength, and it'll look pretty dang good on there. So these are the three pieces that we have to actually put together. So again, just to give you kind of a visual reference here, this is basically what we're creating. So not too hard to build these and put them together or anything, don't require anything fancy. Just put them up on the edge of my table here and slap a couple tack welds down, and then we'll fully weld them in just a moment. A couple quick autogenous tack welds, that should do the trick. Always seems to. Now, of course, pay attention to which side that these need to go on. So if you weld it on like this way and then you flipped it over and you weld it on this way, if I was to weld it on just like this right now, it would technically be backwards. So make sure you pay attention to which way you have your tabs set up. Alright, now we're ready for full welding. Alright, so I let them cool down a little bit, and I got some tack welds on them real quick, just bolted in place. Everything measures out and we're good to go. So now it's just a matter of firing off some really strong, good penetrating welds on these, because again, they're since everything sits so ridiculously low, it's gonna take a lot of abuse. So make sure that you get some really solid welds in there. Now normally I would weld this with the TIG to make sure that I get a really solid weld, but in this area it's kind of limited access for me to make sure that I get it all in there, and the MIG will actually do a great job, providing that you know how to use it, in which I'm certified and I do. So I'm just going to buzz it down with the MIG nice and strong, make sure that it comes out great.